The question number one, they're asking you, this shows a bar magnet suspended by a spring over a coil. The coil is connected to a sensitive 0 meter millivoltmeter. Okay, so this is a voltmeter, and there is a coil, and this is a magnet, and there is a spring attached with it. The lower end of the magnet is pushed down into the upper end of the coil, held at rest. During the movement, an EMF is induced in the coil. So the meter shows a deflection to the right and then return to zero. Explain why this EMF happens. So basically, this is a magnet. There is a pole on the lower side. Let's put this the pole 1, and the second pole will be on the upper side. So there will be magnetic field line. Those are coming from the pole. Okay, so when you move the magnet into the coil, the magnetic field line passing through the coil will change. So basically the answer should be magnetic field lines passing through coil are changing. Okay, so that will produce the EMF. State what happened to the needle of the meter when the magnet is released from rest and pulled up by the string. Okay, so in the previous part it was coming downward and the deflection was towards the right side. Okay, so now it is going up. So when you move it up, the needle the needle the needle deflects to the left. Okay, in second part, the magnet continue to oscillate up and down, moving in and out of the coil with each oscillation. So what will happen? The needle will deflect right and left. Okay, in the next question, there is a transformer. What we have a voltage of primary coil, number of turns, and we have a voltage of secondary coil. We have to find number of turns in the secondary coil. Okay, so we have to use transformer equation, that is ns over np is equals to vs over vp. So you have to find vs. So taking this vp on the right side, you have to find ns basically. So ns is equals to vs divided by vp multiplied by np. So putting the values, vs was 6 divided by 240 multiplied by 800, that will give you 200. Okay, in the second part, the current in the primary coil is 0.050. You have to calculate the power input to the transformer. So power is basically voltage into current. So input power will be voltage in primary multiplied by current in primary. So voltage in primary was 240. Okay, so it's 240 multiplied by 0.05. Answer will be 12 and watts. Okay, question number 2. 90% of the power input to the transformer is transferred to the lamp. Calculate the current in the lamp. Okay, so you have to calculate the current. 90% of the power, so 90% of 12, you have to find those. 90 multiplied by 12 divided by 100, that will be 10.8 watt. Okay, so power in the output is is into vs. You have to find is is p divided by vs. 10.8 divided by secondary voltage was 6 divided by 6, so that will give you 1.8 ampere. Okay, moving to the next question, represents a transformer. You have to name the process by which a changing current in the primary coil P causes a changing current in the secondary coil. That is called electromagnetic induction. Okay, This process is called electromagnetic induction. Suggest a material used for the coil. Explain why this material is used. Okay, we use copper because it's a good conductor. Okay. In part B, the input to the primary coil is 240 and the number of turns are 8000. The voltage obtained between the terminal AB is 12. Calculate the number of turns of the winders. So it's the same. You have transformer equation NS over NP is equals to Vs over Vp. We have to find this NS. So basically NS will be Vs divided by Vp is into NP. Okay, so Vs is 12 divided by 240 into 8000. So it will be 400. Okay, in the second part, the resistor connected between the terminal A and B is replaced by 12-watt lamp connected in parallel. The current in each lamp is 1.5 ampere. Calculate the coil in calculate the current in coil P, assuming the transformer is 100% efficient. Okay, so basically you have to calculate the current in coil P. Okay, so for the current we can use, and the power is 100%, means the input power is equals to output power. Okay, input power is IPVP and output power is ISVS. We have to find IP. So IP will be ISVS divided by VP. We have values of voltages, both voltages, and we have a current in the secondary coil. Okay, right? So calculating it, we will get 0.3 ampere. Question 3. A solenoid is held in a vertical position. The solenoid is connected to a sensitive center zero ammeter. A vertical bar magnet is held stationary at position X. This is position X. Just above the upper end of the solenoid, this is the solenoid. And as shown in the figure, the magnet is released and falls through the solenoid. During the initial stage of the fall, the sensitive ammeter shows a small deflection to the left. Explain why the ammeter shows deflection. It's the same phenomena. Basically, there are magnetic field lines coming out of the north pole. So when it come downward, the magnetic field line passing through the coil will change. They will basically increase. So the answer will be magnetic field line, magnetic field lines cutting solenoid will change. Okay, the magnet passes the middle point of the solenoid and continue to fall. It reaches position Y. Position Y is this position below the magnet. Okay, so the magnet pass described and explain what is observed on the ammeter as the magnet fall from the middle point of the solenoid to position Y. Okay, so in the first position, when it was coming close to the coil, this was the position when it was coming close to the coil. Okay, so the deflection was on the left side. Now the magnet is moving away from the coil. This is basically, it's moving away. This was moving towards the coil. Okay, so now the scenario is different, so the deflection will also be in the opposite direction. So deflection will be in opposite direction. and more current will be produced because because magnet at position y is moving faster as compared to position x. Okay, so at position y the magnet was moving faster because it's freely falling. It's falling from the solenoid, so the position will be great, the velocity will be greater at position y as compared to the x. So when there is a more velocity, more speed, the more current will be induced. Okay, suggest two changes to the operators that would increase the initial deflection of the ammeter. Okay, what we can do, use we can use strong magnets, and we can increase increase number of turns of coil. Okay, so these are the two methods. Question number 4 shows two separate coil of wire wound around an iron core, and AC supply is connected across the primary coil. Okay, and 12-watt lamp is connected across the secondary coil. The lamp glows with a normal brightness. State the name of the device shown. So it's a transformer. Explain why there is a current in the lamp. So we have to explain the phenomena of the working principle of the transformer basically. So current is AC current is provided to primary coil that produce changing magnetic field. Magnetic field lines also cut through secondary coil and induce EMF. Okay, so that is the explanation. The coil connected to the lamp has 450 turns. The EMF of the AC supply is 240. Calculate the number of turns of the coil connected to the AC supply. So we have to calculate the number of turns of primary coil. Okay, so using the transformer equation, NP over NS is equals to VP over VS. So NP is equals to VP divided by VS multiplied by NS. Okay, so the EMF of the AC supply is 240 it was the AC supply. So AC supply is with the primary coil. Okay, so 240, and number of turns are 450, and voltage of 12 watt. Okay, so it will be 9,000 tons. Okay, a 240 DC supply is used instead of 240 AC supply. Tick one box to indicate what happened to the lamp. So it will not glow. Why? Because transformer will never work on DC. It only work on AC. Okay, so for transformer we always need a alternating current. And the next question shows the gap between the N pole and the south pole of the magnet. The magnet field in the gap is uniform. On figure 10.1, draw 4 field lines to show the pattern and direction of magnetic field in the gap. Show horizontal copper. Okay, so you have to indicate the direction of magnetic field lines. Okay, it's start from the north and end at the south. Okay, part B shows a horizontal copper wire PQ between two opposite magnetic poles. A circuit is made by connecting a sensitive digital ammeter between P and Q. The wire PQ is then moved vertically downward. State and explain what is observed on the ammeter. Okay, so it is the case when you move this PQ wire, there is a magnetic field going from north to south. Okay, so it will pass through the magnetic field lines. So when the magnetic field line passing through the wire change, they will produce EMF. Okay, so state and explain when wire pass through magnetic field lines, magnetic field lines, field lines cutting through wire will change and induce EMF. Okay, we get current on ammeter. State what is observed on the ammeter when PQ is moved vertically downward at a greater speed. Okay, when you move it vertically downward at a greater speed, then deflection increased. Okay, increasing the speed will increase the direction vertically upward at the same speed is same and direction is opposite. So the current will current will reverse. Okay, yeah, or you can write on deflection. Okay, this is a digital meter, so we can't say deflection. Its current will increase, magnitude will remain same. Current will increase and current will reverse and magnitude will remain same because the speed is same. Okay, remain same. Question number 6. The output of an AC generator in a power station is 5000 watts. The transformer increases the voltage to 115,000 watts before the electrical power is transmitted to the distance town. State and explain using a relevant equation one advantage of transmitting electrical power at a high voltage. Okay, so we first have to write down the equation. So power loss is I square R. So increasing the voltage decrease the current and power loss will also be decreased if more current will flow, more power loss due to heat heat produced. Okay, the transformer contain two coils, the primary coil and the secondary coil. State the other main component of the transformer and the material from which it is made. Okay, so apart from the coils, the material used is called iron core. Okay, second, state the component in the transformer to which the AC generator is connected. AC generator is connected with the primary coil. Okay, generator gives the input. There are 400 turns on the primary coil. Calculate the number of turns in the secondary coil. Okay, so we have the voltages. Again, we have to use transformer equation. Ns over Np is equals to Vs over Vp. So Ns is equals to Vs divided by Vp multiplied by Np. Putting the values 400 into 115,000 divided by 5000, we get 9200 tons. Okay. In part C, the transformer within the town reduced the voltage to 230. Suggest one reason for this. Less voltage mean less insulation needed, or we can say that it is safe to use. Okay,